All right, this is part 2 of 8.4, volume of rectangular prisms. How can I find the volume of a rectangular prism with fractional edge lengths? You know, we keep doing this fraction thing because fractions are so scary to students, but they really aren't that bad. And I should just go over the fact that I know you probably learned volume is always length times width times height. That's not true. We learned right now that volume of a prism is actually the area of the base times the height. And the reason that this is related to what you've learned before is that when you learn it a second time, when you're learning to find the volume of this prism, you should understand it better than the first time. So as soon as it says find the volume of a prism, you should know, well, volume is going to be equal to capital B times H, right? And then you should also know that that capital B stands for the area of the base, because if you find how many squares, and let's do something weird, let's make the right side the base this time. Why not? Because the right side has a parallel and congruent left side. If you find the number of squares it takes to cover this right side, it's the same as the number of cubes, and then you can just multiply across to find the volume. So put our line down the middle. I'll do a little better line than the last one. Okay, what is this base? It's a rectangle. How do you find the area of a rectangle? Length times width. That's why it's length times width. That capital B became length times width. And hopefully you're good enough to know if this was a triangular prism, then the area formula for the base would be the area of a triangle. It'd be length times width divided by 2. But since it's a rectangle, it can be L times W times H. And now we substitute in our length and our width and our height. And this time I'm going to make the same thing as before. Use my parentheses. Okay. So length times width. Let's say the length is 1 1/3 and the width is 1/2. So 1 1/3 feet. The width, let's say, is 1/2 feet. And the parallel distance between the bases. Well, the left and the right rectangles are the bases. So what's the perpendicular distance between them? It's the 1. So that's going to be 1 foot. 1 foot. Now I can hear you. You're like, do I have to put the units when I substitute in? No, you don't. You don't have to. I'm doing it just to show you why it's feet cubed. I was trying to fix that one, but as you can see, I have this really bomb.com technology, and I just don't. Can he do it? Kind of. Okay, not great, but yeah, you guys get the point. Oh, okay. So 1 1/3 times 1/2. Oh, how do you multiply a mixed number times a fraction? You convert that mixed number into an improper fraction. 3 make a whole. You have one whole here. That's 3. Plus 1 is 4. 4/3 feet. I'm just using the dots now. Why not? 1/2 of a foot. And then times that 1. Can you do it better? Not really. 1 foot. Looks like a really bad one. Not horrible, but I've seen better. Okay, fractions. I just multiply numerator times numerator. That's 4 times 1. Is this 1 in the numerator? Yes, because there's no roof over its head. No fraction bar above its head, so it's in the numerator. 4 times 1 is 4 times 1 is 4 again. 4 over. Denominator, 3 times 2 times. A missing denominator means that that denominator is 1. So 3 times 2 is 6, times 1 is 6. And oh, I have 4/6. I typed that into Big Ideas and it says it's wrong. I didn't see that the 2 and the 4 cross canceled. I can reduce this. 2 is a common factor of 4 and 6. You can write that as 2/3. Good job if you saw that right from the beginning. Feet times feet times feet is feet cubed. So the volume is 2/3 feet cubed. And as you can see, this is not my best video, but I think you all get it, so we'll be okay. Okay, now that we're done, I think I said in the last video, we should estimate if this makes sense. This is 1, but do you see how these two sides, like this is 1 1/3 times 1/2. This isn't even a whole cube. Well, I should say it's only fraction, right? It's only half tall. So this isn't even a whole square. So it doesn't even represent a whole cube on the right side times 1. So we should only get a fraction of a perfect cube. It will not fit inside of this. It's too small. So don't forget to estimate the approximate volume to be more sure you have the correct volume. Remember, you're finding the number of blanks it takes to fill in the 3D space. The number of cubes, volume is cubes. Volume is cubia. Also remember to convert the mixed number into improper fractions. Improper means the numerator, the top, is greater than the denominator, the bottom. All right, everybody, that is it for volume. I hope you do awesome on this. And please, as always, let me know if you have any questions on Google Classroom. Keep it very, very real.